Hello, good afternoon. My name is Carlos Lizarraga, and be, I will be talking today about data visualization libraries using Python. So we can find the notes in the data science wiki, and just going to share the link in the chat. And we're going to be looking for data visualization libraries in Python. And we started this topic last week, so today we will continue with analyzing all the different examples using a Jupyter Notebook on Google Colab. So let's go in. And basically, we mentioned last week that you have several options for doing data visualization using Python. You have two types of libraries, those which are non-interactive plots and those that are interactive. And the interactive plots will be Altair and also Plotly. And the non-interactive plots will be the rest of the libraries. I'm sorry, Bokeh is the interactive one. So in Python, Matplotlib is the basic library, and it was the first library in everything. You can do almost everything using Matplotlib, but then you have to know or write all the different commands to handle the different parts of the plot. But then they came out with Seaborn based on Matplotlib, and Seaborn just is a set of macros that makes plotting a little bit more easier and professional. So you don't have to write all the different codes of lines of codes. But anyway, you can still combine Matplotlib commands inside Seaborn or together with Seaborn. And then if you come from the R world or R users, you have Plot9 and ggplot. Those are Python libraries that just follow all the same grammar as in ggplot2, so you don't have to learn anything new. Okay. So we mentioned that we have different libraries. So we have pandas, we have matplotlib, we have Seaborn, and then we have some other Plot9. And so let's jump to the Jupyter Notebook for this workshop. And if you open it, and then it will give you the possibility to open it in your Google account. So you just select Open in Colab, and you will end up with this Jupyter Notebook. Okay. So I expect everyone to be in this point. If not, just let me know. Or if you have any questions, just open your microphone and ask the questions. Okay. So let us review again. We load all the different libraries in our Jupyter Notebook. So Pandas is the basic Python library for handling data, cleaning your data. NumPy is a numerical Python, so it includes all the different mathematical functions like square root or all the trigonometric functions and special functions, etc. The visualization library, so you have Matplotlib. We are going to import it and call MPL. And also we're going to import this PyPlot sublibrary from Matplotlib and call it PLT. We're going to import Seaborn and call it SNS. And we will import Plotly Express and call it PX. Plotly, it's a commercial company, so they have a free version for users, which is Plotly Express, and the only difference is that if we want to have an interactive plot and show it to everyone else, we need to have a paid account. But otherwise, our plot will be interactive inside our Jupyter Notebook. And then Plot9 is just the library if you are an R user. So you can, if you have a script for creating plots in ggplot2 in R, you can just bring your scripts into Plot9 and it will work the same. Okay, and then we talk about the different ways of creating a plot inside Matplotlib, and one was using the object-oriented style, the first method, which is defining different variables like the figure and the axis. So, and then once you have this variable AX or the axis, you just add all the different functions. Like in this case, we have an X array of 100 points between 0 and 5. That's a numerical Python linspace function. And then we're going to create several plots. So we have subplots and we have the figure size 10 in horizontal units and 6 in the vertical units. And then we will add a grid. We will plot X versus sine of X and label it. Remember that I told you that Matplotlib understands the syntax of LaTeX. So this is just LaTeX notation for the sine of X. And the second plot will be X versus X. And this is the label, linear X. X versus X cubed. So we have cubed X. And then we plot the sum of these functions, X minus X cubed over 6. And we're going to be using a dashed line, and we're going to label it using LaTeX notation. Then we can arrange or control the Y and X limits. So in the X limits, I just want to have looking at the area between 0 and pi over 2. In the Y axis, I want to have only from 0 to 1.5. And then I'm going to define where I want the X ticks to be located. So I want only X ticks on 0, 0.25 times pi, and 0.25 times pi. And then, so I just want ticks on X, pi over 8, pi over 4, 3 pi over 8, and pi over 2. So this is the LaTeX notation, or these are the labels I want to put in the X ticks, specific X ticks I define. And then I will add an X label, the X axis, and a Y label for the function of X. And then we're going to set a title for the whole plots, so simple function plots. And then we will add the legend, which will determine which function it is by the colors and lines. So this is the result of the legend. So we are plotting several functions. We have the sine function, which is in blue, this one. And also we have the linear X, we have the cubic X, which is the green one, and then the sum of X minus X cubed over 6, which is the red dashed line. Okay, so this, from your Calculus 101, this is the Taylor series approximation of the two first terms of the sine function. Okay, and this is the title, and we have the X label, and also we have the specific X ticks we wanted, and also we are using LaTeX to annotate the labels of the X ticks. And so that's one way of doing it. The another way is just using pyplot. So we're going to do again the same plot. We have the X between 0 and 5, I have 100 points. And then I select the figure size. I ask to have a grid. And then I'm going to use the matplotlib pyplot to plot x versus sine of x versus x versus x cubed, and also x versus x minus x cubed over 6. And I use different labels for each function and different types of lines. And then I control the x and y limits for the window. And then also I'm going to be putting the same number of x ticks and also the labels that I'm going to be using there. And then the rest of the labels for the x and y axis and the title and the legend. And I have the same plot again, doing using a different method. So those are the basic two methods, and then you can combine the methods and to create your plots that you want to do. Okay. Okay, so what if you want to have multiple plots? Again, we can create an x-axis for the first plot, a y-axis for the first plot, and then the second plot will be x2 and y2. So on the first plot, I'm going to use x between 0 and 5. And then I'm going to plot the function cosine of 2 pi times x times the exponential of 2 minus x. And the second function will be a new linspace. X2 will be from 0 to 2. And the function will be cosine of 2 pi times x. In this case, the second x. And then the first method using the axis method for the object-oriented. And so you have now two functions, ax1, ax2, or two axes. And you will have a subplots. So you will have two plots in a single column. And this is the width and the height. And then this is the title for the whole set of multiplots. And then the first plot is just, we add a grid. We use the plot function for x1 versus y1. I'm going to be using a dots, dashed. And then I'm going to be using the labels, cosine of 2 pi x times the exponential to the minus x. And I'm going to set a y label, damped oscillation. And the second plot, I do something different, the same thing, but just apply to the second plot, ax2 with grid. And also I'm going to plot x2 versus y2, and I'm going to use a dot dash. And then I'm going to label the x-axis and y-axis. And then I'm going to create a plot. So now I have two plots. The first one is the damped oscillator, and the second one is just the undamped oscillator. So we have two plots in one column. I can go back and change these two numbers. So if I say 1, 2, then I will create two plots in a single row. So now I'm just creating two plots in a single column. And the other one is just similar using pyplot. So instead of AX notation, I'm just going to use the PLT plot or subplot. In this case, again, I'm going to be using two plots, one column, two plots, and then with grid and create the same type of plots. Okay. So this is what we talked last week. And the same way you can produce 3D plots or three-dimensional plots. So in that case, after you import the pyplot and the matplotlib, and this is the color maps, and I'm going to import NumPy, and then I'm going to import this library, matplotlib toolkits, and I'm going to import some test data for creating a three-dimensional plot. So I'm going to define this variable fig. It's a figure size, and then I define some aspect because I'm now plotting a three-dimensional plot, and then you have to define where are you seeing the plot from, like the viewpoint. And then we create the first plot. So I'm going to create um, a multiple plot, so two plots, right? Two plots, one row, projection 3D, and then I define the x-axis, the y-axis. So I'm just plotting between 5 and -5 and 5 every 0.125. The same thing with y. And then I'm going to plot a mesh grid for xy, and then I'm going to define r as the square root of x squared plus y squared, and then c will be just related with the sine of r. And then I'm going to plot a surface of x, y, z, and these are just parameters, the stride, the c stride, and the color map, cool warm, the line width, and also I'm handling this variable anti-alias so in order to avoid some reflections, and then set the z limits or in the vertical direction, and then I'm going to use the color bar. So that's the first plot, this one, and then I'm going to create the second plot. The second plot will be just wireframe. So I'm going to add the second plot by these variables, and also I'm going to use now, instead of a surface, I'm going to use a wireframe, and wireframe is just the structure. So this is the second plot. This is a wireframe, and this is a surface plot. And I have the, sorry, and I have the color map here on the first surface plot. Okay, so that's very quick overview what is matplotlib and the two ways of making single plots. I mean, when you have the mathematical equation for plotting, and also to create three-dimensional plots. The same thing applies if you have a data set, two-dimensional, three-dimensional plots, you can do the same. Okay, so let's go back and now read this penguins data set and try to use this data with the different plotting functions. So I'm going to, I don't think, yes. Okay, so let me load the libraries. Will complain, yes. Okay, let me comment this out. Because I need to install this library, which I'm not going to use, I think. Okay, so again, load the libraries, except this one. And then I'm going to read using the pandas read CSV to read this CSV file, which has all the data from the different penguin species. And this is the data set. So I have species, island, and some dimensions of the different species elements, and also I have the gender. And then I think I mentioned last time, if you're using Google Colab, you can activate what type of plots you can do for a specific data set. So you have all the different options, and whatever option you want to select, then it will give you the code for creating this one. So you can show the code. It will have all the code you need to create this type of plot. So Google Colab now makes plotting easier using Python, because once you view the recommended plots, then it will tell you what plots you can create, and also it will give you the code. Okay. All right. So let's continue. So this is Google Colab created your plots using Seaborn and the scatter plot function, and you have that df is just the data frame, and the x variable is the Coulomb length, and the y variable is the Coulomb depth, and it's using a species for color, separating the three species. So now you have the three species of penguins separated by colors. So that's a scatter plot. Okay, so we continue with the data frame. We use the info function from pandas to get to know the general characteristics of your data frame. This data frame has a problem with one of the rows. One of the rows, instead of male or female, has a dot. So we need to eliminate that row. So we're going to only keep the rows for which the sex is different. So this is the different sign. Is not equal to dot. And well, so I execute that. And now I have, everything is now clean. All my data set is clean. So let's create, let's use the different libraries. So what if we want to create multiple plots? So this is the way of doing it. So I'm going to create 3 subplots. So I'm going to add, this is the object-oriented way. So I'm going to define AX1, AX2, and AX3. And each figure, this is AX1, this is AX2. So these are the 2 columns, 2 rows. So 2 columns, 2 rows, the first one, 2 columns, 2 rows, the second one, 2 columns, 2 rows, the third figure. So this is how you create. And then once you create the boxes to create your plots later, then you come back and now start filling your boxes, your empty boxes. So now on the first figure, I'm going to AX1. I'm going to plot a histogram of the body mass variable using 20 bins and color blue and transparency 0.4. On the second box, I'm going to use the scatter function of the Coulomb length versus the Coulomb depth in color orange, and I'm going to use marker inverted triangles. And on the third box, I'm going to do a box plot of the flipper length. So execute. I'm just using matplotlib. Now I have the 3 boxes. Okay. And then once you have the 3 boxes, maybe you want now to start adding labels. So that's the next step, adding the ticks, the labels, and the legends. So I have 3 plots, AX1, AX2, and AX3. And now I'm going to, on the first one, I'm going to set the X ticks, 3,000, 4,000, 5,000, 6,000, and I'm going to put X ticks labels, 3, 4, 5, and 6. So I'm changing from grams to kilograms, and then set some title, penguins mass distribution by kilograms. And I'm rotating the X ticks labels in order not to have it vertical. And I'm also using a font size small. On the second plot, I put these X ticks and I put these X ticks labels rotated also. And the X labels just the Coulomb length, and the Y ticks, I also select specific Y ticks. And then I put the Y label and the title. And on the third plot, I'm going to avoid putting anything on the X label because it's conflicting with probably with having all the different plots together. So also I control the Y ticks and Y ticks labels and set the Y label in title. And then I execute. And then I will have these. Okay, I'm going to add a semicolon here. And you will avoid this warning. So let's see if I can eliminate that. Yeah, no. What else? Okay. Okay, anyway. So I have the general title, Antarctica Penguins Dataset, which is the superior title. And then I have the title for each plot. And also I have defined the X ticks and Y ticks. And also I have rotated the labels. And so I now have three types of plots. Okay, so that's the way you can do multiple plots using Matplotlib. And then let's go to the scatter plots. So the scatter plots is just shows a relationship between two variables. And in this case, I'm going to use Matplotlib. Again, I'm going to be defining two variables, labels and categories. And then I'm going to factorize the data set by species. And then I'm going to use this color map. And also I'm going to put the labels on the different data. So I'm going to use scatter, and I'm going to show the scatter plot between body mass and flipper length using the colors defined by this function or this color map. And then I'm going to get coordinate axes to know where to put the X label, the Y label, and the title, and then plot the legend for the species. So I execute that, and I now have a scatter plot using Matplotlib. Let me make a little bit smaller. Okay. So that's doing it with Matplotlib. Let me do it now, or let's do it a correlation map. Correlation map using the core function from Pandas. So I'm just going to compute the correlation on the data frame, and then I'm going to use Pandas to create this color matrix or correlation matrix. And it doesn't look very nice. But then I tried to do using Matplotlib, and then I don't get any desired output. So the best way of creating a correlation map is using Seaborn. So Seaborn is just going to use the heat map function of the correlation matrix, and I want to have the annotations true, meaning that showing the correlations. And I'm going to use this color map, full worm. So I execute, and now I have the correlation matrix. But the correlation matrix, the diagonal, it's always one because everything is correlated with itself. And then this matrix is symmetric, so the upper triangle matrix is equal to the lower triangular matrix, so we don't need to show the second part. So one way of doing that is using a masked correlation heat map. So I'm going to use this mask and also just keep the lower part of the triangle matrix. And now you have a better way of presenting your correlation matrix. Okay, so everything, for example, the body mass is highly correlated with the flipper length. That means the more mass one penguin has, the larger the flipper length is going to be, or vice versa. And anti-correlation will be like the flipper length versus the culmen depth. So the larger the flipper length, the smaller the culmen depth, etc. Okay. We can use Plotly Express to create also a heat map. And I'm going to execute this. And this is the correlation matrix. this is the correlation matrix, and it's interactive. Wherever you put your pointer, it will give you the information, and also creates this distribution of the variables. In this case, the body mass, and in this case will be the flipper length, and also you have the color map table of the correlation. So the clear yellow will be highest correlation. So the highest correlation will be between the body mass and the flipper length. And this is anti-correlated or low correlation, body mass and the flipper length. Okay. You can print the values for the correlation. Yes. Okay. So the next type of plots will be histograms. You can create histograms using pandas, just df hist, and also you're selecting one variable, body mass, 10 bins, grid through. The width of the bars will be 0.9, color blue, transparency 0.5, and fill blue, so it's not empty. So it's just a simple histogram. I can do it using pyplot or matplotlib again, and I have this plot, right? There's a 0 here on one of the values, and then I can do it with Seaborn, just a single SNS hist plot of the variable, and I don't give any additional information, but Seaborn will put some default values. So the amount of code I need to write using Seaborn compared to the amount of information I have to code with pyplot or even pandas. So Seaborn makes my life easier. I can do the same thing using Plotly Express. So I'm going to use Plotly histogram function, and I just specify the variable body mass. And this is the histogram interactive, so it tells you what are the values of the different variables. What if I try to do it using Plot9? So if you have used ggplot, it's just ggplot syntax. So ggplot, the data frame, the aesthetics, x is body mass, plus some geometry for the histograms, 10 bins, transparency 0.5, color blue, and then create. And then you have your histogram using Plot9 or similar to ggplot2. So those are histograms. Now let's go to bar plots. Doing or creating bar plots using pandas. So I select a column of your data frame. I'm going to count the different values of the species, and then I'm going to plot bar plot and color blue. So execute, and it creates your bar plot of counting the different species by species. Okay. We can do horizontal plots. Just I'm going to, instead of bar plot, I'm going to use bar horizontal. And then I can do group by function from Python to group the penguins by species, and flipper length, computing the mean, and then plotting a bar plot. So it's just a sequence of functions, and I have a bar plot of the mean flipper length of the penguins by species. And I think this is the same. This is for the flipper length, and this is for the body mass, also computing the mean and creating a bar plot for the mean weight of the penguins. I can use, again, group by island, species, and sex, compute the mean, and plot bar using pandas. So I will have a histogram of the penguins by gender and body mass. Okay. Now, if I want to do using Seaborn, I don't have to I just need to specify what columns I want to. So I want to separate, do a bar plot, separated by species, and I'm going to do a bar plot of the flipper length, and I'm going to set the title. So execute, and now I have the flipper length. Okay. Or I can, instead of a bar plot, I want to separate by gender. So I'm using the same. X is the island, and Y is the body mass, and Q is going to be the sex. And now I have like a dodged histogram or bar plots, sorry. So you see, if you're using Seaborn, you don't have to, everything comes with several defaults. So you just need to specify what exactly you need to plot, and it will create it. The kernel density estimate, you can use pandas, very, well, it will give you the information, but not very well presentation for your papers. So what you can do is use Seaborn Facet Grid and separate by species color. And then in this case, I'm plotting the flipper length and adding a legend. So you have, wow, okay, some warnings. But this is your kernel density estimate by species of the flipper length, and this is the distribution. Okay. Box plots, the next type of plots. Using pandas, box plot, DF box plot, then what column. So you're going to be doing a box plot for every variable, numerical variable. So you get this. It will just give you an idea how the distribution of your data set is. Then we can do, again, pandas. I'm just going to add some title and Y labels of the flipper length. So by species, this is the flipper length. You see all the different labels in the x-axis are overlapped, so you need to rotate your labels. If you're using Seaborn, you just need to know by species and then flipper length, and the data set is DF, and it will create your box plot. And we can add some title. So it's very easy to use Seaborn. Or culmin length, we can orient vertical. Okay. And there's this other one called catplot from Seaborn. You can do a separation by the species and gender. No, by island, I'm sorry. Species and island. So you have the box plot for each island, for each species. So there's no chinstrap or gentoo in the Torgensen Island, or you don't have chinstrap in the Pisco Island, and you don't have gentoo in the Trim Island in Antarctica. The next interesting plot is violin plots. So violin plots, you can find them using Seaborn. So I can create this violin plot. Oh, height. What happened? Let me take this out. . . 。 . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay. No, I didn't complain. All right. So I have a distribution of body mass by island for the different species. So so Adelie, it lives in the tree exists in the three islands. Chinstrap only exists in the Dream Island, and Gentoo only on the Visco Island. And this is the violin plot. It's similar to the box plot. The white line is just the median, and then you have the quartiles. The first quartile will be the one down there, second, third, and fourth quartile. So the distribution of data are there. Or you can do separate by gender. So you have violin plot. This is the body mass distribution by gender for every species. So you will see that the male penguins are heavier than the female penguins. And then you can modify this plot to make a gap between the two um, different data sets. So now I have a gap between the male and female for the body mass for the different species. So those are the violin plots. You can do violin plots using Plotly Express. So the function is violin, and then you're going to be using color for island and separated by species. So these are for every island, you have the body mass distribution. And since it's Plotly Express, it's interactive. And this stays interactive in your Jupyter notebook. If you print it, then you lose everything, of course. So that's the advantage of Plotly Express. Then scatter plots using pandas. You have to write all these lines of code using the scatter plot scatter. And so you have a panda scatter plot separated by species, okay, for the flipper length versus the body mass. Or you can use matplotlib pyplot. And again, you have to write all this code to create a presentable scatter plot, okay, by species, where you are using different markers for every species, and you define some colors. Okay, so these are the markers, the circles, and the triangles, and the squares. Using Seaborn doesn't require too much instructions. So you just set the figure size, and you're using probably some style like white grid. And then scatter plot is the function for the data frame, the variable X body mass versus flipper length. And you're going to use the species as color and style for the markers using the island. Okay, so this is the legend. So species by color and the island by marker. So this is your scatter plot. So this is actually like a four-dimensional plot, since you have 2 dimensions for the flipper and body mass, and then you add a color. This is a new dimension for the species and another dimension for the island. So this is a 4-dimensional plot. Okay. We have another function from Seaborn, lmplot, and creates a similar scatter plot. Okay. Or you can use facet grid. So remember, there's always more than one way of producing your plots in Python or using these libraries. And if you want to find a way of creating a plot, just go to the manual and look for the different galleries of examples, and every example will have the piece of code, and then you adapt it to your needs. Okay. I have an example using Bokeh for a scatter plot. Of course, it's a different way of notation and functions. I'm not going to go into the detail, but I just going to look at how the what it didn't came out. Okay, skip that. Plotly express scatter plot, function scatter, and I have color species and symbol species, and it's interactive. Okay, so it's good to it's a good tool to find or identify different um, data values. So that's Plotly Express. Using Plot9, scatter plot, the same thing as ggplot. So you add the data frame, the aesthetics, the X and Y axis and color species. You add points and labels for X, Y, and title. So you create a ggplot2 style plot using your script from R in Python. Another example of PyPlot for another scatter plot. You have colors, you define the color tables, handles, and the scatter plot of the body mass versus flipper length using the color map defined here. And then set up the legend so you can create this one. Okay. This is Seaborn Facet Grid. So what you have is a collection of scatter plots depending on your variables. It can show you some relationship between the flipper length and the body mass for every species. I find this function scatter matrix from pandas useful. It will tell you what is there is you can see simply if there is a relationship or correlation between the different variables, and on the diagonal you have a histogram. So this is the histogram of the Coulomb length, and this is the histogram for the Coulomb depth, etc. Flipper length and body mass. But okay, Bokeh, will it work? Nope, didn't work. Okay, and Seaborn per plot, I think is the last one. It just gives you a general overview. Again, correlations, if there is some correlation between the variables, and on the diagonal you have the, instead of the histograms that you got from pandas, you have the kernel density estimate of that variable. So that will help you do a that exploratory data analysis of your data set. Or you can use per plot again, but change the type of a plot in the diagonal. So we're using histograms instead of kernel density estimates, and you get, you can see if there is a relationship between the different variables. Okay, so in short, a very fast trip using two different Python libraries. So you don't have to be stick to one library when you're trying to produce a specific type of plot. The best way of doing it is once you see something in the internet, try to see what is the code, and then try to adapt it to your case. And sometimes, like in this case, bokeh will imply too many lines of code, and then probably won't work. So find pieces of code that produce a plot and then try to adapt it to your case. So that's my general overview of the different Python options for doing data visualization. And your libraries to go to, first will be Seaborn and then Matplotlib, or if you create something in Seaborn, you can combine with Matplotlib functions or instructions. And then if you need to have an interactive plot, then probably Plotly Express will be my next bet. And that's about it. So you don't have to know everything, just Seaborn notation and Matplotlib notation, and maybe Pandas, very simple way of producing very basic plots, like when you're trying to explore data and you don't want to go into all the detail of importing more libraries. Okay, so that's what I have. Do you have any questions for me or?